And here's the final part of the lesson. When you're going through this, if you want to revise later, the full version, the full video is on YouTube as well. Plus, by the way, I'm going to be giving each of you a flash drive with all the material on it, all the material for your advanced maths from grade 11 and for grade 12. And it's going to have these lessons on it as well. I guess I don't know why I'm telling you that if you're already watching it, hey? Yes. Okay, so let's go. Notice now we have a trigonometric. This is very interesting, having an x combined with a trigonometric graph. Negative pi to pi is a bit extreme, actually. I have it in this example, but in the exercise I've given you, I've done 0 to pi, so you don't have masses of extra work. So, derivative 1. Cos 2x is a composite function, so it's derivative of the outside minus sign, so it becomes plus sign. So it's minus sign 2x times 2 for the derivative of the inside. So that's where that 2 comes from. That's the derivative of the inside. Equal to 0. So here we have a trigonometric equation. We need to do the full general solution first. So degrees, this is going to be 180 plus 30 plus K360, 360 minus 30 plus K360 for third and fourth quadrants where sign is negative. And changing that to, because you need to work in radians in fact, 180, so that's pi plus pi by 6 is 30. 2k pi, well, 360 is 2 pi. And then 2 pi minus pi by 6, and that's 2 pi, so this is plus 2k pi, k element of z. And we found you can solve in angles if you want to and then convert to radians, but they're the answers in radians. And your graph needs to be drawn in radians clearly because you have x's and cos of x. Second derivative, sin 2x becomes cos 2x, and then you have to multiply by the derivative of the inside function, so it's 4 cos 2x. And now I need to substitute each of these values in. Just use your calculator. Less than 0, negative 1, 3, so local maximum. And I've substituted negative 1, 3 into the original to get the negative 0, 44. Remember to put your calculator on radians, but please remember to take it back again to degrees. And there are the 4 tests. I'm sure you see what I mean by being a bit extreme, having negative pi to pi. I'm afraid I think that there's another example. I think it's also negative pi to pi. Sorry about that. Y-intercept of 1. We substitute 0 into this. 0 minus cos of 0. And cos of 0 is 1. So now we're going to slot them. Notice, comes out a slot. Oh, so corny. Right, let's slot onto the axes what we have so far. So there are our 4. Now we need to find the intercepts. We know that's going to go there, so it's got to go up here somewhere. So we know we're going to have one about here, up there, down there, and up there. So there's only one x-intercept, in fact. Y-intercept of -1. And there we're getting our x-intercept there. So it's about 0.5. Looks about 0.5. So let's use 0.5 in our Newton's method. I've really shortened it now because I'm sure you'll be able to, you know the derivative anyway, well, the original and then the derivative below. If you substitute the 0.5 into that formula, we get negative, we get 0.52. I'm just having a look to see. Right. Strictly speaking, you stop there because it's 0.5, and there, that's exactly what I've done. Because 0.52 approximates to 0.5 again, so we can use 0.5 as the value. And there is our graph. Remember, this follows the PowerPoint as well, if you want to watch on the PowerPoint. Here's another one. Cos 2x minus sin x. So it's actually two trigonometric functions together. So derivative. Using chain rule, minus sin 2x times 2. 2 being the derivative of the inside function, minus cos x, equal to 0. So I use the double angle formula. Sin 2x is 2 sin x cos x, so I end up with 4 sin x cos x, and I've changed the signs throughout the equation. Factorize, and that gives me two possibilities. Now you know how to solve these, so you solve these for negative pi. You see this one here is 90 degrees. If you think about the curve of a cos, where's it naught? Well, it's at 90 degrees and then every 180 after that. So it's 90 degrees plus k 180. And then for this one, it's 180 plus and 360 minus, being for third and fourth quadrant. And we do a sine minus 1 on 0.2 out on the actual value. It's a coincidence that that's 0.25 and we get 0.25 as an angle. And we get general solution, and so therefore we know there are our answers. You see, that's outside the range and that's outside the range, so we'll have to subtract 6,28 and subtract 6,28. That's how we got these values. Now we do our second derivative. Greater than 0, so then I'll just do the tests. Notice I've substituted these into the original to find the y values. This is quite complex for an exam. I don't think you'd have one this complex in an exam. But it's just to give you a bit of practice at it. Y-intercept, 1. So, let's take those and we're going to slot onto the axes. Right, so we're going to have an x-intercept where it touches on there. There are 2 intercepts we need to estimate. We use Newton's rule, Newton's method. So there's the original function and there's the derivative of that function. Great, comes back with the same number. Substitute 0,5 and it comes back with 0,5. So there is my graph. At this stage, you can now do the third question on the exercise sheet that you have. As I said to you, I've made it simple. I've only made the third question, I've only made it 0 to pi. And it's the easier, it's the first type of trigonometric involvement in the graph.